Hi everyone, hope you're doing well. This is a short one today. It's only page 41 and page 42, kind of a review of everything, so it shouldn't take you too much to understand everything. Okay, hope you guys are well and this is still. All right, let's take a look at page 41. On page 41, they're basically asking you to do two things. Solve for x, which in this case, x is the height of this cone. So when I look at that, I'm like, oh, that's part of a right triangle. So if I find the right angle, this must be C. I'll make 5A. So I'm actually looking for B. So I set up the Pythagorean theorem, drop everything in. 5 squared plus x squared equals 10 squared. 25 plus x squared equals 100. Take away the 25 because it's on the other side. So x squared is going to equal 75. And if I take the square root of 75, we're going to have to round that off because it's not a perfect square. So square root 75 is 8.6. We'll round it up to 8.7. We'll round things to the nearest tenth today. So 8.7. Then it asks you, okay, so now that's the height. So when I want to find the volume, I wouldn't have been able to do that unless I did the Pythagorean theorem first. So pi times my radius I already know is 5 squared, but now I know my height is 8.7. So again, for this case today, we'll use 3.14 for pi. So again, I'm just going to type all this in my calculator and say, okay, start with fraction key, 1 divided by 3, and then, oops, wait, I got this in the wrong mode. So a lot of you are asking me, like sometimes your calculator, if it's in math print mode, looks different than the other mode. So just be careful. And sometimes it'll leave your answer in terms of pi, but you can fix that by just going to classic mode. And then times 3.14 times 5 squared, and then times 8.7. If I hit enter, I get 227.65. So that would be centimeters cubed because it's volume. Okay, that's it for that one. Okay, now on this next one, it's asking to find x. Now x is actually from the top of the cube to the bottom of the other corner. This is called the central diagonal, okay, because it cuts through the air and goes to the other side. It's not on the floor. It's not like floor to floor or ceiling to ceiling. It's actually going through the air from top to bottom. So in this case, it's asking us to figure that out. But again, if you look carefully, it's part of this right triangle right here. So if this is 15, this is 15 also, because it's a cube, they're all the same, or it's a rectangular prism, they're all kind of the same height. So in this case, no, it is a cube. So everything is 15 all around. That's 15 inches too. But to use my Pythagorean theorem that I'm going to need to get x, then when I look at this, x is actually c. So my legs are 15 squared and the square root of 450 squared equals x squared, which is that line. So I know that's 225. Whenever you square a square root, you actually just get back the number underneath. Okay, so that's x squared. And if I add those two together, then I get 675 equals x squared. I do not know what that is off the top of my head, so square root of 675 is 25.98. So 25, oh, so actually that'd be like, if I rounded to the nearest tenth, 26.0. Okay, so that's how many inches x is. Now, to get the volume, you don't really need this number because it's a cube, everything's the same. So it's 15 times 15 times 15, which is actually 15 cubed. So I can just do that and go 15 caret key 3, and my answer is 3375 inches cubed. Okay, not too bad. All right, cylinder, same idea. The first thing we have to get is x. Well, x is a leg on there, and the hypotenuse would be the 25, so I'll call that A and 7B. And if I drop it into my formula, then x squared plus 7 squared should equal 25 squared. Okay, so x squared plus 49 equals 625. If I take away the 49, then I'm going to get 625 minus 49 is 576 equals x squared. And I take the square root of that, 576, in my calculator, and I actually get a nice number, 24. So that was a perfect square. So 24, again, is the height, 24 centimeters is the height of that cylinder. So I needed that number for me to finish doing this. And the radius is 7 squared. The height is, now I know, 24. So if I wanted to get this answer to the nearest tenth, I'm going to plug in 3.14 times 7 squared times 24. And it should give you 3692.364, and that would be centimeters cubed. Okay, so that's it for that one. And then we're back to another cone. So again, if I look here, it's asking you to find the radius. So, but I know that this outside 4 is the same as this inside 4. So I know that's 4 centimeters. So my legs would be these two, and my hypotenuse is 5. So if I use the Pythagorean theorem, if you're getting sick of that, you probably say it in your sleep. 4 squared plus r squared then equals 5 squared. So we got 16 plus r squared equals 25. Take away 16, r squared equals 9. I know the square root of 9 without a calculator, it's 3. So 3 centimeters is the radius. So I'll need that over here when I plug in 1/3 times pi times 3 to squared times the height, which is 4. Remember, you want the center height, not the slant height. So if I simplify all that, 3 squared is 9, 9 times 4 is 36, a third of 36 is 12, 12 pi, and if I want to plug in 3.14, then 12 times 3.14 equals 37.68 centimeters cubed. That's it. So basically these problems are saying, well, you have to use Pythagorean first in order to get something that you need in the volume formula. That's basically how these are going. Okay. All right. One last question on the next page. Some people get a little confused with this because the diagram looks a little strange, but they want you to find two things here. Okay. So this is a rectangular prism. So the first thing it says is find the length of the diagonal of the base. Okay. The base is on the bottom. So that's this one. So if I look at that, that's X. So when I look at this, they're saying that this is a right angle. So this is actually C, because you have, if it's a cone, you know, I know it's hard to tell, but if it, the box corners would be at a right angle. So one of the bases is 9.5. That could be your A, and this could be your B. So the first thing you can do is you can solve this one just by using the Pythagorean theorem. So I'll plug in 9.5 squared plus 16.8 squared equals x squared, which is the length of the bottom diagonal. So I need my calculator for this for sure. So 9.5 squared turns out to be 90.25. 16.8 squared turns out to be 282.24 equals x squared. So if I add those two together, 90.25 plus that, I get 372.49 equals x squared, and I'm going to have to take the square root of that. So square root of 372.49 equals, x would equal 19.3. That's how many feet the bottom diagonal is. This is a pretty big carton, okay? So to go from there. Now it says find the angle of the central diagonal. So on the other page, we talked about central diagonal being from the top to the bottom, like through the air, through the center of the carton. So in this case, it's Y, but then it's all part of this right triangle right here. So what helped us in part A is that we know that X is now 19.3. We can, and we don't have two variables anymore. We're just going to figure out what Y is, and Y is the hypotenuse. So 52.1 and 19.3 are going to be your legs. So we can do this. We can say, again, in the Pythagorean theorem, that this time 19.3 squared plus 52.1 squared is going to equal y squared. Now, I already know what 19.3 is squared. It's 372.49 because I just did it above. but I need my calculator to do 52.1 squared. So when I do that, ooh, big number, 2714.41 equals y squared. Add to it the 372.49, and you get 3086.9, and that's what I need to take the square root of. So when I do that, 3086.9, I get 55, we'll round it off to 55.6 feet. And that's it. So that's all you're really doing today, is working with the Pythagorean theorem a lot and a little bit of volume, kind of a little bit of review. And then that should take you to the end. So the homework in the packet, that would be page 43. So it's asking you to find the missing side and also find the volume if you need to. So you can look at each shape and say, okay, yep, the volume is a cube. That would just be side cubed. This one, the volume formula, don't forget, is a cone, 1/3 pi r squared h. This one's a cylinder, so the volume is pi r squared h, not 1/3. A sphere, don't forget, is 4/3 pi r cubed. And this one's a little tricky. I'm going to give you a hint. They want you to find the distance from here to here, but the first thing you got to do is find the distance from here to here. And since you don't know what those are x and x. We did a problem like this a little bit earlier in your notes. If you want to check back, see if you can get it, or look at the key and figure it out later. Okay, good luck.